Right, so we'll try the same thing for the 100 surface. This is actually in the context of silicon, but it's convenient to use the gallium arsenide crystal structure with the two differently coloured plastic beads, although of course in this case both colours represent a silicon atom. And it's useful because the two colours represent the two different atoms within the two atom basis set, which is also formed for the silicon crystal, in the silicon crystal, which has got the diamond crystal structure and has also got two atoms per unit cell and has a face-centered cubic crystal structure. So we're looking down and we can see the square symmetry of the 100 face reflecting the cubic symmetry. But we can just try and pick out now where the top of the unit cell would be. So we've got this pink, these are the corners, pink, pink, over here, this one, so it's got a bit of black on it, but that atom, and that atom. So we've got that square being formed. And this is the centre of the face of the top of the unit cell. So that's the top of our unit cell. So that's the arrangement of the atoms. But in fact, if we pan back a little bit and try and understand the bonding, you can see that it's a little bit more less symmetric than the square arrangement that we've implied, because this atom here has got bonds which are only in one direction. They're unidirectional, the bonds which that silicon surface atom has retained, and they run in a particular crystallographic direction. In fact, if we looked along that row, so we're going to look in from this direction, we just pan down there, maybe this will be recognizable now. You see that we're looking along the 110 direction. So again, we've got those big cavities, and just coming around a little bit, you can see that we've got this these bonds going up and down. So these are the surface atoms. They've got two bonds, one going down to each of these two blue atoms. To the back, these are the back bonds to the bulk. But each atom would have had two bonds which are would have been coming out in this direction. But these have been lost at the surface, those layers have been removed. So if we look down, for instance, at a bulk atom, here, for instance, again, we've got two bonds going down to the lower layer, blue atoms, still silicon atoms, and we would have had these two bonds going up to the higher layers. And it's these two bonds that are no longer present at the surface. So at the surface, we've got two dangling bonds associated with each of these surface atoms, which are running along a particular crystallographic direction. Okay.